Hello everyone, Nubasaurus here, about 2 days after Christmas, and just bringing you a brief update on the Skittlebits project over here. So as far as changes are concerned, a lot has happened since the last video update. I'll be going through each part methodically, but for now let's start with the CPU. So this is the CPU right here. If you couldn't figure that out, you should probably get your head checked, but this is the Skittlebits CPU, and of course, as tradition, I've got a redstone pixel art smack in the center. But that whole thing is done. It is 100% functional. It can run all of its RISC-based instructions, as well as subfunctions for CISC-based instructions. And I've got it in a nice, neat little package so that it can be placed anywhere in the world and built around with clearly marked pins and yeah. So it's all, like I said, it's all self-contained for the majority of the part. There are a few things that are external, as you'll soon find out, but things like reset and interrupt control and wait times, those are all managed in the computer. All you need to do is provide a clock and a data source, really. So it's like I said, it's all self-contained. It's all fairly straightforward. But of course, it's not entirely a complete system. Like I said, there are pieces that are external that are required for the system to run. I mean, you really only need 2, maybe 3 to actually get the system running, but there are 5 external pieces that are required to have a full computer, to use. So we're going to go through the systems right now. So the first one we've got here is the Sis Construction Bank. Now, like I said, this thing is predominantly RISC instructions. It runs very, very simple instructions. They're nothing more than move instructions, and then a few control instructions. And then, of course, you might be wondering, well, how does it do arithmetic and logic? Those are nothing more than move through the ALU. So if you want to do some more complex instructions, you store those in the CISC bank, and those are basically just strings of RISC instructions. So what it does is it calls on the instructions in here, and it runs the instructions that are stored in here, and performs much more complicated instructions. So that just makes the CPU much, much more versatile, and that's really the aim of the game here. That's what I was going for with the whole system, was versatility and power and expansionability. But I guess that falls under versatility. But I want it to be compact, powerful, and expandable. Those were the 3 requirements that I wanted for this computer, and I got them. And of course, that's the first thing that I wanted to point out is the CISC bank, because it's extremely expandable. It stores 1024 16-bit addresses, or sorry, 1024 16-bit locations. So that's 2048 bytes, or 2 kilobytes of data that it can access. And yeah, and like I said, you can have up to that. I think I have about, what do I have, like a quarter of a K in here at this point. So you can get a lot of CISC-based instructions in here. But at this point, I just entered in there the ones that I need. I think I only have like 32 different CISC instructions. Now, they haven't been programmed in yet, so this is pretty much just a blank slate. But as soon as they're in there, I can call upon them and run those functions. Theoretically, anyway. I haven't tested it out, but it should work. The next system is, well, it's a small one. This is basically has something to do with the way the computer addresses I/O. So you can address 256 I/O components because we've got an 8-bit addressing bus. Now we've of course got a bidirectional data bus, but what the I/O address bus is it's basically just tapped from that bus and stored in a register. So that register, if you want to access any I/O, needs to be there. And like I said, it just sends out an I/O address, and you can use that to access one of a number of I/O peripherals. At this point, there's only one I/O peripheral on here, but like I said, you can have up to 256. So it's very, very expandable, very, very powerful. And then, of course, this is just the control bus. These are all your reads, writes, ALE, lines, stuff like that. So this is pretty much your central bus, which everything is connected to, which includes data, I/O address, and control. And then that is branched off to the address control unit, which we covered on in the last video. But I did some modifications. Now it's totally expandable up to 64 bits very, very easily. All you have to do is just take a section of this and stack it 64 times, and then change these to however many bytes you have. So at this point I've got it set to 2 bytes because it's a 16-bit address at this point. And the number of bytes is always going to be the number that's presented into here plus 1. So we're actually reading it backwards. So it's actually 001, which is 1 in binary, plus 1 makes for 2 bytes. So if you wanted the full 8 bytes or 64 bits, you flip all those down, which would make 111 or 7. Plus 1 makes 8. So yeah, like I said, all you have to do is just expand it and then modify the levers a bit. So it's super easy to modify and expand. And at this point, like I said, I've got a 16-bit address system going on. So, and I think that's probably more than I'll ever need. In fact, 1 byte would probably have been enough, but I figured go big or go home. So yeah, that's the changes to that. And like I said, it's all functioning right now. It's been hooked up to the computer, and the computer is now controlling it. So as you can see, it's been counting for a little bit. We're nearing what is that? 128 memory locations. So like 3 bytes away from, 3 clock cycles away from 128 memory locations accessed. So that's awesome. I was just watching this thing count up, and it's done quite a few cycles. Because this computer is so simple, and a lot of the stuff is close together, the clock cycles can be extremely quick. I find this the fastest it can be is at about 1 hertz, or cycling every half second. So it's pretty quick. I'll give it that. At this point, I think I've got it set to about 7 ticks per oscillation, or 14 ticks total for a full cycle. So here's the clock down here, which is pretty quick considering that the last computer I built required a 20-tick clock cycle. So drastically faster in comparison. Yeah, what else is there? So then, of course, that's complementing the speed and everything, and just how quickly it's able to access different addresses. And then the final piece that I've got installed here is the interrupt control module. And so what this is it's a module that has, if we can get to it, 8 interrupt pins. And all this thing does is it prioritizes the interrupts. So if 2 interrupts come in at the same time, it'll always take the one that's of higher priority. It'll generate a interrupt request line or signal, which will go to the computer, and the computer will then acknowledge the interrupt request. And the way it does that is basically runs a memory read cycle, but instead of setting memory read to low, it sets interrupt acknowledge to low. And what that does is, rather than reading from RAM at that point, you're now reading from this. So this will send the appropriate byte based on the interrupt that it's currently addressing. And then of course it can send up to 16 bytes. So then we've got a counter every time it reads from the system. It increments the counter. So each time you read it, you get a different byte, and this allows you to send strings of bytes rather than just a single byte. So you can run a jump command, you can run an interrupt command, or you can just run a string of different commands that you maybe wanted to run before returning to the main program. So it's totally versatile. You can give it whatever you want, really. There's no limitations here. And then of course there's another section to the memory right here, which just stores the maximum amount of bytes per interrupt. And what that does is when this counter equals the number in there, it'll automatically reset, so there's no need to do any resetting manually. And then I said that there are 5 pieces. I've only shown you 4. The last one is actually the memory. Now the memory I haven't built yet, but again, it's kind of a vital piece if you want a computer to run. But that's where I'm at with all this at this point, so I just need to build the memory. I need to program the interrupt control system and the Sis Bank, and then I want to add a few I/O peripherals, because I figured, I've already got the I/O expansion bus. I may as well add a couple of those. I figured, some timers and I/O pins will be just fine. But yeah, I think we are nearing completion of this computer, and I feel a trailer will be made for this thing fairly soon. So yeah, that said, that's really all I wanted to show you. So thanks for watching. Hope you enjoyed. Follow me on Twitter for frequent updates on this computer, and I'll see you guys in the next video.